A bicyclist headed east at a rate of 20 miles per hour. An hour later, her sister left the same spot in a car headed east at a rate of 60 miles per hour. How long will the bicyclist have been riding when her sister catches up to her? Now, in this problem, we're asked how long the bicyclist will have been riding when her sister catches up, but we also don't know how long her sister was driving at this time. So even though they only ask how long the bicyclist has been riding, there's a second unknown. We also don't know how long her sister's been driving. So I'm actually going to write two let statements here. Let the bicyclist's time be x, and let her sister's time be y. Now let's set up our table. Again, we have rate or speed times time equals distance. And we have the bicyclist and her sister who's in a car. All right. So let's fill in the chart. The rate or the speed of the bicyclist, we're told, is 20 miles per hour. And her sister driving in the car, that is 60 miles per hour. The time that the bicyclist spends is x, and her sister's time is y. And to get the distance, we multiply across. 20 times x is 20x, and 60 times y is 60y. Now, we need two equations that model the situation. One piece of information that we haven't used is that the bicyclist's sister leaves an hour later. That means the bicyclist is going an extra hour than her sister is going, if we're comparing the times. We can write that as an equation. The bicyclist's time is x is equal to 1 hour more than her sister's time. Well, that's going to be y plus 1. So that's one equation that we have. The other piece of information that we haven't used is the fact that we're looking to see when the sister catches up to the bicyclist. If they start in the same location, and at that moment the sister is catching up to the bicyclist, that means that the distances that they've traveled have to be the same. They have to be equal to each other because she's caught up with her sister. So that means that 20x is equal to 60y. Now we have our system of equations and we can solve. I'm going to use substitution because we already have one of the variables isolated. X is equal to y plus 1. So wherever I see an x in the other equation, I'm going to replace it with y plus 1. So we have 20 times y plus 1 equals 60y. If we distribute the 20 on the left, that gives us 20y plus 20 equals 60y. We have y terms on both sides. We need to get rid of one. I'm going to subtract 20y on both sides of the equation. That gives us 20 equals 40y. To get y alone, we divide by 40. And this gives us 1/2 equals y. So we know that her sister's time is 1/2 hour. Hours because everything here is measured in hours. All of the times are measured in hours. We need to know the bicyclist's time, though. That's what they asked us for, and that's x. But we know that x is y plus 1. Since y is 1/2, x is 1/2 plus 1, which is 1.5, or 3/2, or 1.5. Doesn't matter. 1 and 1/2 hours. And they asked, how long will the bicyclist have been riding when her sister catches up with her? We can say the bicyclist will have been riding for 1.5 hours. And that's our final answer.